All right. So let's get started. So let's plot with Python. So that's like what I would like to walk everyone through today. So using Python to generate some basic plots first. But the big benefits of using Python is that there are a lot more than just data visualization. I mean, if only data visualization alone, there are so many options that we can play around if we Google like data charts and stuff like that. But in terms of machine learning or data science, like many algorithms have been like developed within the Python community. And yeah, it's probably any question you have with Python, there are 90% chance that there are going to be someone answered or written some codes that you can copy and use. And that's how I learned to use Python by myself. I just Google stuff and try to understand each part of the codes. So as today, we're going to talking about data visualization. So actually I have grabbed some of the summary charts to help us decide which type of data we would like to, which kind of plots that we would like to plot our data based on our data that we have. So in these charts, you'll see that they're divided the charts into like 4 main types. Like if you would like to looking for relationships, you can plot like scatter charts for 2 variables, and you can change the size of each data point, and that's called bubble charts for 3 variables, or change the colors of the data points. That's another way to present 3-dimensional data within the 2D scatter plots and things like that. Like if you would like to show the distribution of the data, you can use histogram. You can use line histogram. So these are like many options that Python can do. Actually, any plotting software can do. Like Tableau is the one that I also use for exploring my data as well. It's like drag and drop. And if people interested in using Tableau, I can also like do some tutorial for Tableau as well. But for Python, it's almost everything we can do with it. Similar to MATLAB, but the reason I really like Python over the MATLAB is the way the codes we write. It's more user friendly, in my opinion. It's more like human readable. Like we read the lines and we kind of understand what these lines suggest, even though we haven't had used the codes before. And you will see some of the examples today. And I just would like to introduce you to this website that I just found out. It's similar to what I showed you. Like there are decision charts that you can go and see what kind of your data, and is it numeric, whether it's 1 variable, 2 variable, and this person has like created the decision tree, and you can decide which type of plots that you wanted to plot. And if you going into each type, you can see that he using different programming languages to create those plots. So he also have Python galleries. And if we going into each galleries, he have an example codes and like how each chart can be plotted using Python and stuff like that. So that's one of the here. So here is one of the good resources to see and play around with different type of data charts that we can plot using Python. So yeah, and some of the basic plots that we normally plot is bar plot, histogram, scatter, line chart, and stuff like that. But today for the sake of our time constraint, I will just going to show you the scatter plots and the sea surface temperature plot on the maps. That's what I'm trying to cover today. So that's like roughly an introduction about what we can do with Python in terms of data visualizations. So maybe it's not very well informed for everyone who's not familiar with Python right now, but I think it will be more easier to understand what I'm talking about by just doing it on your own on the Jupyter notebook. So as I have sent out an email yesterday, but I sent out, it's not very early in the week. So some of you might haven't had installed it yet. So we just gonna do it together if you haven't have an installation. So to install Python on to your computer, there are like several ways that we can do it. You can only install Python, which will be a different methods that I'm going to present you today. But the one way that we can do it is to install Python using the Anaconda installation package. And Anaconda is kind of a platform that you can run different kind of programming languages, but the Anaconda, they're gonna manage your environment, meaning that they're gonna manage if you install new packages of the Python libraries into your base environment. Anaconda will make sure that each libraries are compatible to each other. One of the problem that people might struggle with if you install Python by yourself is that you might install NumPy libraries with one version and you install SciPy libraries with the version that is not compatible with each other, then you cannot run the codes. So by having Anaconda doing the installations of those libraries or packages, it will make sure that everything is compatible with each other when we wanted to run the codes. So if you're going to Anaconda, you will see these homepage, and when you click download, it will direct you to the installer packages for each operating systems. So if you click on the link that I put it here, it will direct you to these Anaconda website, and if you click download, it will move you down to the end of the page, and you can download whichever installation you wanted to download. I also trying to find out the difference between 64-bit and 32-bit. Actually, it's not much different in terms of the basic things that we do by just plotting scatter plot and stuff like that. But I found that using 64-bit will help improve the performance when we do something more fancy, like doing big data analytics, doing like some of the functions that it requires higher computing power and stuff like that. So if your computer specs allow you to install the 64 bits, I think it's better to go with the 64 bits. But if your computer it's a little bit on the lower side of the computing capacity, maybe 32-bit is just fine in our plotting purposes. And when you download the installation package already, I think it's just like other software. You open the execution files and then click next, and choose all the recommended settings. But what you might wanted to change is the directory. If you wanted to save it on the D drive instead of C drive, if you have like a small space on C drive, you can do that when you install it as well. But after the installation finish, at this point, I just would like to make sure that everyone can open the terminal from Anaconda prompt, something like that. So at this point, I will just pause and see if everyone can successfully install the Anaconda or not up to this point, if there are any questions. Or just let me know if you can install the Anaconda prompt.
My one was already installed, but it was really nice the way you showed. I wish I knew this before.
All right.
I already installed.
I think Bamsu said you haven't used Jupyter Notebook before, I think. So then
I saw your email and I installed it this morning too.
Okay. And how is Natalie? Have you installed? Nice. And charging, okay. So I'm not sure, Igor, would you like to install, or maybe later, we can do it later together as well. We can have a one-on-one sessions too. I think he's not on this.
Yeah.
All right, so I think everyone has an Anaconda prompt. So just make sure that you have Python 3 on your list. So to do that, on the command prompt, we just type conda list. And I believe everyone probably, on the Anaconda prompt, if you can see here, we can type conda list. And when we type conda list in our Anaconda prompt terminal, it will print out all the packages that we have installed on the base environment. If you have learned that from other places, we can create it a different and working environment. We can like create a dedicated environment that we want to install a certain packages and don't want these packages to impact our base environment. We can do that as well. But in my presentation, I will do everything on the base environment. So when we install any packages, it's going to be in our base environment, and we will use everything on the base environment. So we don't have to worry about whether we open the right sub environments or something like that or not. And I believe everyone have Python 3.83, something like that. Everyone should be 3.8.
3.85.
That's fine as well. Newer than me, so that's good. And it's changed pretty fast. So it's changing pretty fast because there are a lot of people working on improving the Python. All right. So everyone have Python 3.8 now. Now, actually, right now we can coding Python from our terminal, but this is for people who are programmer, I believe, and I am not smart enough to like really coding things on the terminal. But just to make sure that we are installed everything properly, so in our Anaconda prompt, we can type Python. So right now it's gonna change from showing you base, which means base environment on Anaconda, to these 3 arrows. So by showing these 3 arrows, it means that we are now in Python program, and we can code anything right now. Like we can doing this most classic example of doing coding, which is print hello world. And it's gonna print hello world here, which means our Python works properly. And that's just how to verify whether we installed Python. I'm not sure, Igor, I just mentioned that we can do it one-on-one sessions as well, whenever you wanted to, like really wanted to play around with Python. Right? So this is one way to verify that we have installed our Python 3 on our PC properly and it's run fine. And then when we would like to quit from these Python from our Anaconda prompt, we can just type quit and then close and open bracket. And that will quit from Python and coming back to base environment. And that's it. That's what I only know how to code on the terminal, which is not the most effective way for me to do the codings. So what I'm gonna show you next is how to code in the Jupyter Notebook. So Jupyter Notebook is a text editor that we can run the Python coding or other coding languages. But let's see, there are some. Oh, all right. So there are several options for text editor. You might heard like PyCharm, you might heard Atom, you might heard several kind of text editor. But the reason I chose Jupyter Notebook is that it's very simple. It's not that fancy, and you can run the code and you can see the figures in the same cells. It's not like popping up another window of new, like the figure not gonna pop up as a new window as we have for Matlab and things like that. So that's why I chose Jupyter Notebook. And now when we have installed the Anaconda packages, it should have Anaconda Navigator. So two ways that we can access to our Jupyter Notebook is to launch the Jupyter Notebook using the Anaconda Navigator, or we just type Jupyter Notebook from our Windows search and click on the Jupyter Notebook right away. And I think everyone have installed, be able to like open Jupyter Notebook, I believe, right? So if you already launched the Jupyter Notebook, what should pop up is the black window of the Jupyter Notebook terminal, something like this. And it's also gonna pop up your web browser with the base directory wherever you set the base directory at. So at this point, you can put your Jupyter Notebook files anywhere. You can, so you can change directory or whatever, but just to make sure that you put everything in the same folders, I guess, that just to make everything clean and easy to find where is our notebook. So you can create a new folder by click drop down menu new, and it will show you the untitled folder. And you can rename by select the untitled folder and click the rename on top of the list, and you will be able to rename the folder. And that will be your kind of a base directory for your Python 3 notebook. Yeah, if you have done that, I think that's what I have for my presentation. Next gonna be on the Jupyter Notebook. I think that's up until this point. Is there any question?
Thank you, Ronnie.
So
Brilliant, Ronnie.
even though I think I have sent the link to our share drive in our Zoom chat on the first one, and when you click on that, you will see the .ipynb files, which the Jupyter Notebook Python file. And if you can download that and put the file into your directory, into the folder that you just created. After you created the folder right now, you can access to your folder with the file explorer or whatever is on your PC. All right. And you can, when you put your file onto your directory. So right now, this is my current directory, right? So because I linked everything on my OneDrive cloud, and I doing that because I can work on different PC if I wanted to. So I linked my Tamu OneDrive with my PC and with my laptop. And when I open my OneDrive, I can open it from my PC or I can open it from my laptop as well. And right now, I'm putting all of my files in this knowledge sharing, which is my personal folder, not the chat folder yet. But I put the same files, which is these Python visualization underscore RR version 1. If you have put the file onto your directory already, you can just click the file, and then it should pop this file up, and this showing as green because I already opened the files. So I just would like to make sure that everyone can open the file.
I think I can. It's just like my connection is so bad. The Zoom and the Python together is like very slow.
Oh.
So I may be a bit delayed, but please continue,
All right.
and I'm following it. It's brilliant. Just open.
Nice. We'll just wait for everyone. You can open the file.
I need to download. You mean the text data and the WOA data, right?
Yeah, you can download every data into your folder.
Oh.
All right, Navi, good luck.
Download.
Okay, I'm ready.
What did Bamsu say again?
I don't need this one.
I downloaded. I'm ready.
Okay, nice. And if you want to read what I've typed, that will be okay as well. So yeah, I mentioned that this is just.
Still downloading.
I love the hello cute GGDTs. This is awesome.
Not hello world anymore.
Oh. But you know, the Python is an animal. Python.
Yeah, Python is snakes. With the snakes.
Yes, snakes. I'm afraid of snakes.
Oh.
But not of Python.
Not for Python. All right. Are you still downloading?
I'm still downloading. One moment.
All right.
Okay, I'm okay.
Okay. So now you are in your Jupyter notebook. Or maybe just, yeah, maybe doing this right now. So what I type here, first I will just show like different things on the Jupyter notebook first. So if you click on each, I'm not sure whether, so right now I'm still sharing my screen, right? Yes. And you see my notebook, right? So if you can see right now, if I click on these cells that I've typed in text, this is called Markdown text. So this is Markdown, it's not code. So for these cells, when we have print hello QGDGTs, this is the code cells. Sorry, it's a random call.
Now I see what you mean, Ronnie, about this.
Right. So this is the.
Go ahead.
No, I just cut off from my headphone because there are some random call. But what is the question again?
No, I realized I was talking to Ronnie like, was it Tuesday? MATLAB and Python. Ronnie told me about this part right now because in MATLAB you use the what is it the percentage right?
Yeah. Yes.
This one is you don't have to.
Notes. Yeah.
Yeah, we can doing that like Markdown easily, but we also comment things pretty easy here as well. But first thing that you wanted to learn how to run the cell is you can run by click run, and that will run the cell, or you can just control enter, and that will run the cell as well. When you control enter, it will run the cell and you still add that cells. Another choice, the third choice is if you click shift enter. So when you click shift enter right now, it will go to the next active cells. And there are two modes. So right now when your cell is green in color, you are in the editing mode, right? But if you press escape, your cell turns to blue. When your cell turns to blue, it means you are in the command mode. And there are a couple of things that we can use keyboard shortcuts in our command mode. So if you press B on your keyboard, it will create new cells below your current cells, which is a pretty fast way instead of using your mouse and click plus, right?
You mean just enter
press
B?
B.
Press
yes.
B.
Yes. It will create new cell below. And if you press A, it will create new cell above.
Oh, I see.
Yeah. So in case you wanted to try something and you don't want to mess your code in your current cells, you can easily add new lines by just press A or B. If you wanted to add on top, you press A. If you add it below, press B. So let's just doing another quick thing. So maybe x equal 1 plus 2. And you can just control enter to run the cell. You can see that right now it can run, but it's not show the result. So we can put only x in the next line just to print out the result. And right now you don't even have to use print function. It will automatically spit out the result for the calculations. All right.
Well. How do you show the result if you don't use print?
So it's coming out and it's showing you that this x is 3.
I see.
All right. So that's the first basic, like how to run cells and how to add new cells, like new lines, by just press A and B. All right. Next, I have put here like some of the basic Python libraries that we will generally use it when we import the data from Excel and we wanted to do some regression analysis and stuff like that. So these are some of the basic packages that we wanted to install into our base environment. All right. So I'm not sure. Has everyone installed the packages already or not?
I have to install X-ray.
Okay. And you know how to install the packages. I'm not sure Bamsu has you.
Let me see.
So you know how to install it using the terminal, right? My internet connection is bad. Coming back.
I was typing. Yeah, Xiaoxing went out as well. I think it's.
Yeah.
Are you guys in the apartment?
Yes, it's the same apartment. And the
Okay,
internet
this makes sense.
is not very stable. All right, going back. Still, videos you keep recording, right? All right, so if everyone already installed.
No, I didn't install X array.
And do you know how to install the
I
packages?
don't know.
Okay, so you going back, you coming back to
Conda, right?
yeah, your no, yeah, you can do Conda as well, but you can also come to the directory page.
Directory.
And then you click drop down new.
Oh, wait. Where is my room?
Or and then choose terminal. And we can also do this on the Anaconda prompt as well. Either way is fine. All right. So anyone, you can also use your Anaconda prompt. And then I cannot really remember the code. So we can just search conda xarray install. Oh, sorry, install.
Are you in the terminal or the Conda?
Right now we can just use Anaconda prompt.
Okay.
So you open Anaconda prompt, and then instruction. You use this code. So normally what we are looking for is the conda install. And you type, you copy.
Ronnie, I have a question. So the package, the X, for example, the X array is one package within the Python, right?
Yes, but it's a package that can run with the Python.
Okay, if you wish you show the conda list, it should be one of in the list or just.
If it's already in our conda list, it's mean that we probably have it. So you can just check by if you type import xarray in your cell, right? As xr, and then you run. If it cannot run, it means you haven't.
Yeah, I see.
Okay. Yeah, so if you have it in your conda list, also should show xarray. If not, you can just go to xarray website and copy the conda install code and then put it on our Anaconda prompt terminal. And then enter, and it should install. And it should be a few minutes, like it should be 1 to 2 minutes. It shouldn't take that long. And if you installed everything, you should be able to run these cells without any error messages.
Xiaoxing, are you getting how to do it?
No, I already installed, but it still shows no module named xarray.
Did you type properly, or would you like to share your screen?
One moment. It's already installed. And maybe I should restart my Jupyter notebook.
Yeah, I found like Mac sometimes it is so complicated. I had to rename my Python package because I was not able to run. So sometimes all these packages you have to rename for some crazy reason. Hopefully it's not that, but it happened. If it happens with you, know that it also happens with me. Mac
All right.
is trouble sometimes with that.
But right now you're doing okay.
I'm okay. No, I'm not okay.
Can you just share your screen?
I can.
I'm not sure whether I can make you.
No, you don't have
share.
to. I can share.
Okay, nice.
Here.
No module name XRA. And you already installed your XRA, right?
Yeah, I can show you my contact list. I already.
Oh, but Xiaoxing use Mac, right?
No, not Mac.
Oh, right now you use Windows.
Yeah, you can see the contact list XRA is here.
So then
okay.
can you just copy and paste? Let's see. Oh, we will use XRA in the SST Matplot. So if you don't have XRA right now, you can do Matplotlib, which is fine.
Okay, just skip this error.
All right, yeah. But so just get going first. So then if you wanted to run the cell and keep the code, you wanted to comment thing, right? So to comment thing easily, we can just type palm sign in front of the line, right? But easier way that we can do is, if you wanted to comment multiple lines, you can drag and highlight all the lines that you wanted to comment and click Control and slash. And it's just click Control and slash. It will comment every line. You don't have to type each individual line.
Control and slash.
Control slash. Which slash is the one on the left of the right shift. All right. So that will comment every line you highlight.
Nice.
Yeah. Another cool thing about Python is that if you wanted to change something at a multiple location at the same time, you can hold Control and then use your mouse to click several lines, and whatever you type, it will be the same.
Oh, wait. Could you repeat it again, Ronnie?
All right. So if you wanted to change the same variables that have the same name, but you use it multiple locations, you can go and you can hold your Control and then you click at the point that you wanted to make change.
Control, right?
Yeah, Control, and then use your mouse to click. And then you can type whatever you wanted to, or you can backspace whatever you wanted to as well.
Oh, in MATLAB we use Control F to find the variable. Just click the variable, Control F will find all of the variables.
I think we can do that here too. We can find. I think we can do that. I used to do that.
Oh, that's an easier way.
No, but because you will find this function easier for sometimes that you wanted to change parameter names and stuff like that. All right. So if you'll be able to run these cells by just commenting out the XRA, that will be perfect for now. Next will be an introduction of Matplotlib. So it's just I'll just go over some of the basic anatomy of the graphs whenever we wanted to generate a plot, what we have to do, something like that. All right. As is our house. When the dog barking, I hear the double, I hear the real one and I hear from the microphone. All right. So you're able to run these cells, right? So you might not understand it right now, but I will just show you that they are to plot the data, we will need to create figure, and in each figure there will be axis, and the axis is what we have here. Like, so normally we can do this. We have to use this pattern of codes. So fig mean you wanted to create figures, and then comma with x, which mean axis. We wanted to have an axis inside our figure, which in this case, if we wanted to have subplots, there will be multiple axes in one figure, all right? But in this case, if we don't specify number of subplots, we just gonna have one subplot, which means one axis, and that is the code that we normally use to create a figure with a single axis. And if you see the second code, you can see that right now we wanted to plot something on this particular axis, right? So we already named this axis as AX. So whenever we wanted to access the axis in the figure, we have to using that name AX. If we change the name to be AX1 in our first line and we run the cells again, it will not plot anything right now because we plotting on the AX instead of AX1. So if we change, we have to change it both. So if we wanted to change both, as I just told you, we can control click and we can add AX1 in each location, and we run again, and then it will show what we would like to plot. And the general coordinate system in Python is it's x axis come first and then y axis come later. If you not specified anything, if you just put your data arrays in the first position and the second position, it will read your first data array as an x axis, and it will use your second array as an y axis. But we can specify things later as well. So the second cell, I just show you another way that we can input our variable into our plot data. So you can just do x equal to a data array that you wanted to make it at an x, and y as another variable with the same data array that we use on the first example. And when you plot the data, you just use your new variable that you just created. So plot x and y, all right? And if you're okay with that, I would just move on. Okay, next, Matplotlib have two ways to plot the data. So there are object-oriented interface and the PyPlot interface. So PyPlot is like the embedded function of the Matplotlib that it will automatically understand whatever data you put it in, and you don't have to really specify the axes you wanted to access, which is the second example. So the first example is the object-oriented style, which what I normally use and which what I have used in the previous examples. So in these cells, our x now is an array of number from 0 to 2. So linspace is one good function that we can create equally spaced number arrays. So in this case, we created number from 0 to 2 and have 100 numbers. And if we wanted to see how our x look like, we can just create another cell and run. And you can see that that's the number arrays that we use NumPy linear spacing, all right? So NP is as what we imported our NumPy package, we import NumPy as NP. So right now, whenever we wanted to use NumPy, we have to type NP and followed by whatever function in NumPy packages that we wanted to use. And linspace is one of the common one that I generally use it a lot. So that is 100 numbers between 0 to 2. All right, so that is our X. And we can, the same, created the figure and we name our axis. And whenever we wanted to plot things on our axis, we have to declare the axis and then using plot function. And right now we plot X versus X and we can put label inside. And these will show you the blue line, right? So if I comment everything out except this label line, so except this label line, it will show you one line. And if you wanted to add another line on your same plot, you can do it by write another line, but using the same AX, and it will show you the second data set plot on the same charts. And it will be more make sense when we have multiple subplots and we wanted to plot a certain data on the same subplot, something like that, all right? And if we're doing it again, it will be 3 data points, data sets on our same plots, right? And these are all of the cosmetic parts of plotting. It's like you set the label, you set the x-axis, y-axis, which I will talk about it when we're using the ProPlot packages, because I'm not using a lot of Matplotlib packages, so I'm more familiar with ProPlots, and it will be slightly different in terms of coding style that you will see, all right? And the second style is the PyPlot style, which I normally not use it, but we can do it whenever we have our variable ready to plot. You can just type plot, which means we declare that we're going to use Matplotlib to plot data, right? And PLT is what we import our Matplotlib as, right? We import Matplotlib as PLT. So then we use PLT and then we use the function plot in the Matplotlib libraries. And we put our variables that we wanted to plot. The same, if I comment it out, it will show you one plot. And if I add the second plot, it will show you the second one, and add the third, it will show you the third one. So that's 2 ways to plot data on the figures. But I generally use these first style because it's easier to change stuff whenever you wanted to add subplots and things like that. It will be easier if you have it in these format. All right. Next, it's just I'm going a little bit to like details here, but I hope that the notebook Excel explain itself easily. So again, if we're using, so right now I'm just going to talking about each individual part of the figure, like some basic parts. The first thing is the figure. So if we didn't add axis, like if we didn't add comma and AX inside our command line, it's just gonna create a figure, but it doesn't know what you wanted to have in your figure. You don't know whether you wanted to have an axis of the plot or not, and things like that. So you will have these figure without any axis. So if you wanted to have an axis, you have to declare that you wanted to add axis inside your plot, all right? And if you didn't specify number of subplots, you will get a default, a single axis. But right now, if you specify subplots, like you use plot subplots and you put 1, 2. It means that you wanted to have a subplot in these 1 to 2 dimension. So the first number is number of rows that you wanted to have, and the second number is number of column you wanted to have. So in this case, we created 1 row, 2 column subplot, and in the next example is 2 row, 2 column subplots. All right. And you can see that if you didn't specify the figure size, it will automatically adjust the cell, the size of each axis, right? So if you wanted to like enlarge each individual subplot, you can do by enlarge your figure size. So to do that, you can just add fig size into your subplot bracket. And if you change right now, if I change to be 10, 6, so first number again is horizontal axis, and the second number is vertical axis. So we can change the size of our plot by just changing this number. But if we didn't put anything, it's gonna show a default size like that, all right? Okay, everyone okay up to this point? This is very like step by step. I right.
I have a question. So in the figure, which one? Above this one, you have 2 axes, axis 0, axis 1. Above this figure.
Above this one?
Yeah,
this one, right?
Yeah, axis 0 and axis
AX1. So yeah, I put it like that just to show you that this is one way that we can name our subplot.
But
so
it wouldn't have a difference if you just put AX, right?
It will be different when we wanted to access the plot. I will show you right here. So it will be able to print as well, right? But if you wanted to plot, for an example, if you wanted to plot x, it don't understand which subplot you wanted to plot because you don't specify the number. So in this case, when you get an error, you have to add the index of the subplot, right?
I see.
But if we doing this way,
you can just put the AX
0 and then plot and then x, and it will know that we wanted to plot on this one.
I see. So in that one, you have to specify which axis you want to use.
Yes. So this code is an example of how we can specify it in the first line. But if we don't specify it, it will read this one is number 0 and the next one is number 1. Right? So it will know which one you wanted to plot on. All right.
Thank you.
Okay. So that's the figure part. So next is the axis part of it. So again, I just show you already how to specify which subplot you wanted to plot on. So for an example, in this example, I put these x and y on the first subplot. So I use number 0. And we can also move it to the second subplot by just change the index of the subplots. All right. So that's the same as I explained you judging. So next is I'll just show you an example of this one, and it shows us an error because right now we have 2x2 subplots, right? And when we use the normal Matplotlib packages, right now it don't understand which subplot it is when you put only 0, because how the Matplotlib package read the location of subplot is by coordinates. So instead of putting 0, you have to put 0, 0. And if you want something like
Ronnie,
that.
I have a question. So usually it starts from 0, right? So 0 row, 0 column.
Yes, 0
I see.
row, 0 column. Yes.
Got it.
So if you wanted to move it to the lower right corner, we just put 1, 1. And this is like, if you don't want it to use ProPlot, you have to do this for the Matplotlib. But I will show you the way I do it. So this is how to fix the error that we just have by have only 0 in these for 2x2 subplots. With the traditional Matplotlib, you have to plot using coordinates. But if you use ProPlot packages, which is a wrapper mean all of the codes will be based on the Matplotlib packages, but they modify something and made it easier for users to just code it. So right now, what difference between these cell and these cell is that instead of using PLT, right now I'm using PLOT. And when I using PLOT packages is the ProPlot that we install. So we install ProPlot as PLOT instead of PLT, right? So when we using ProPlot right now, it's understand, even though we're using only one number index. So right now I shows you that I plot it on the first cell and then it's count to the right first before it start on a new line. So this is 0, 1, 2, 3. So if I wanted to move this plot to the last plot, I can do by just change the number from 0 to 3. All right. So that's how can we access to different subplots by using ProPlot. It's just a little bit easier for me in terms of writing codes. All right. Next. So that's the basic for plotting stuff. Next, we will just try to plot scatter plots from our Tierney and Tingley text statistics data. And right now, because our input files is CSV files or Excel spreadsheet, which similar case, we will use the Panda packages. So because I think I already import pandas earlier, so we definitely don't need to import pandas again if we already do like at the first line. But if not, we can do it here as well. So when we import pandas, we will use the function panda read CSV, panda.read_CSV, and you will have to put the full directory path with your file name in order to open it. So at this point, I would like to ask you to change the directory path wherever you put the CSV file on your computer. And if you chain it correctly, you will be able to run the cell and you will get these tabulated data, which is what we call data frame for Panda. So that's why we normally use DF, because it's data frame. All right. So whenever you have question about pandas, about data frame, you just have to Google pandas or data frame in your query.
So the path in Python usually two dash line? No, not dash line.
The backslash you mean, right? So this
Yeah,
is
yeah, yeah,
something
backslash.
that's a little bit tricky. So whenever if we copy our path from the window, right here,
Yeah.
I paste it. It's only one
Yeah, that's
backslash, and it's don't understand it. So what we have to do is we have to add a backslash by just doing what I told you. I taught you already the control click, and then we add backslash. Or we can do it another way. If we don't want it to use a double backslash, we have to invert the direction of the slash, and it will understand the same as well.
Sorry, and after the ProPlot, you have this. You put it you continue to the training plot, right?
Again, please.
Ronnie, after you explain the ProPlot, then you move on to the tyranny plot, right? Right, what you're doing right now, right?
Yes.
Okay. I don't know why I don't see it in my file. 1.1, right?
Have you download the one that I just put in our share drive? Because the one that I sent out with an email is not the latest one. I just add some stuff.
Gotcha.
All right.
Wait. Two X 2.
Can you run it now? I will just wait Bomsu as well. I have seen that Diane's have some plots from Python already, so I think you'll probably cover.
Yeah, some things are already did, but like all the tips and shortcuts I didn't know, and they're awesome. I'm following well. It's just my computer is going so slow that it appears all the time dizzy, and then I have to wait a little bit. But I'm following.
Okay.
A little bit lagged.
Okay. All right. And it's very oversimplifying a lot of stuff. So if you don't understand anything, just ask me, because I'm trying to think when I first code some of these and what question I have, but there's something that I might miss. So feel free to stop me anytime. So please just let me know whenever you can run.
No such file.
No such file. You wanted to share your screen or not? What?
I'm not sure if I think I'm already installed import pandas. Where? No such file or directory. Directory. Oh, I see. Oh my gosh. Python 2 backslash. Okay.
All right. Bomsu, are you good now?
No,
You go first.
I have the same file not found error.
How about the path? Do you put the right directory?
If you wanted to
At the end of the path,
share.
you have to add 2 backslash.
Yes, just to show is that it's not the file.
Yeah.
It's still a folder.
Yeah. Ronnie, instead of using 2 backslash, could I use 1 front? Usually it's front slash, right?
It's another way, right?
Yeah.
Yeah, you can use that as well.
Oh,
But you have to change every double
that's
backslash.
true. You know, in the type control. On our supercomputer, we usually use the front slash, yeah, the directory.
Yeah, it's either way, because I'm doing this because whenever I copy my directory from the Window Explorer,
Yeah, I saw it. It's backslash.
We have to do that.
Yes.
Okay, I'm ready.
All right. And I just would like to point it out that in this code, I put skip row 1 because from the CSV file that we download from the website, the first line is something that is not the header of the table. So we have to skip that. So we have to skip row 1. All right. So right now we have our data frame, and the dimension of our data frame is 19 columns and 1095 rows. All right. Now we wanted to plot. So in this case, I'm going to show you how to plot text86 and SST data versus latitude. So we first gonna grab 3 variables from 3 columns and put it in our new variables, which I'm doing it right here. And this is the way we grab the column. We can do it this way, or we can do it this way as well. I will show you another way. So if we do text 86 new, we can also doing. So what we have to do is that we first declare our new variable name, and then we equal to our data frame. And instead of using the dot and column name, we can do the square bracket and put our column name in the quotation mark. That will also, this is like the typical way that people doing it. But if our column name doesn't have any space bar inside the name, we can do it easily by just using dot instead of open this square bracket. So that's these are the same, like your text86 data will grab from the text86 column into our new variable, right? And we're doing the same for latitude and sea surface temperature. And I just would like to show that normally you would like to see what is your column name, right? So you have to like scroll over back and forth. But one way you can print all the column names is by using function columns, which is the built-in function for pandas. So to do that, you just type your data frame name and then dot and followed by columns. And that will print you all of the column that you have in your data frame, which will be easier to see like what kind of columns we have. So we have text86, we have depth, have SST, like different kind of SST. We have like each individual fraction of GD to T and stuff like that. All right. So what we need now is 3 variables, x86, latitude, and C-surface temperature. So next, I just show you to plot 2 subplots. One is x86 versus latitude, and the second one is C-surface temperature versus latitude. And you might see something new here, which is chair Y. And because ProPlot is trying to make things easier for users, so they already assume that whenever you create 2 subplots, you wanted to share your axis. So if we don't add anything, what they're gonna plot you is that they're gonna understand that your x-axis and y-axis for both subplot is the same thing. It's the same
You
parameter.
mean use the same Y?
Yes, using the same y. And also using the same data range for x as well. But in this case, we plot 2 different things, which our y-axis is different, right? So right now, our first subplot is x86, and our second subplot is C-surface temperature. So to make the y-axis not shared, we have to doing share y and then make it false. And if you don't know what to do, like if you like not sure what specification that we can edit in our subplot, one way to do it is that you put your cursor inside the bracket, and then you use your keyboard shortcuts. You click Shift Tab Tab.
What was the shortcut?
Shift and then double tap. Shift Tab Tab.
Shift, double tab.
Yeah, on the left side is above cap lock. So Xiaoqing is, so this is left hand shift, right? So tab is the one above it, one above
Oh,
it.
I saw it. Thank you.
So shift tab, if it shows you what are the parameters that we can adjust. And if you, oh, sorry. So if you shift tab and you click the up arrow, it will pop it like in the under. And right now, you know what can you change, what parameters you can change. So you can see that we have these are all default things that the ProPlot put in. So if we don't, right?
So shift, then click tab twice.
Yeah, shift and tab.
Oh,
It's not showing.
It didn't show anything. That's fine.
But that's like, yeah, sometimes it's happened to me as well. I don't know why. But
crazy.
Bonnie, sorry, I have to go. So.
All right.
Yeah, but really, thank you so much for doing this all. I know we talked about that on Tuesday, but
yeah.
Maybe
the part with the plotting of the map, we can make part 2.
Yeah, we can make part 2. We can just finish the scatter plot here and we can do part 2 later.
Yeah, because this is super interesting and also can get very long.
Yes, X-ray can be very long as well. So then, yeah, I think this is going to be the last thing for scatter plots.
Okay, but anyway, thank you. Yeah, thank you, Ronnie. So I'm gonna run out.
And you can at least you can open notebook and code some Python, and that will get you started.
Just one quick question before I go. I wanna. How did you add the mark? Did you say it? Like, you know,
the what again?
Is it the mark?
Mark.
You know, the code, like the sections of just in.
Oh, the Markdown.
Markdown, yeah.
Okay, so to do that, if you create new cells, you will have these as a code cell, right? It will auto generate code cell. You can use drop down menu and choose Markdown as well.
Okay.
And right now you can type and print. Another way to do that. So that's one way. So one way is by going to these drop down and choose Markdown. Another way to do it is that when you create new cells and in the command mode, when your cell is in blue, you can type M. So when you type M, it will change from code cell.
Have what?
Okay.
M.
Yeah. When your cell is blue, you type M, and your cell will change from code to Markdown. And when it marked out, you can put your node and it will just be your Markdown instead of code.
Oh, smart.
Right. And I think that's the beauty of using Jupyter Notebook, as you can like comment or write some ideas without having it as a long commented sections in your code. Yeah.
Oh, it's like called Markdown. Markdown.
I don't know why it's called Markdown, but that's how they call it. All right.
See you guys later.
Yeah, I'll just continue until like finishing the scatter plots, and I think we'll call it for today.
All right.
Bye-bye. All right. So Xiaoxing and Diane, you're okay with these two subplots?
Yeah.
And next is how we're gonna make our plots fancier and fancier. So it's just like all the cosmetic part of it. And we will do all of this in these like scatter command. So again, if you don't know what parameters of the plot you can change, you can do Shift Tab Tab. And it will just
Shift Tab.
Yeah, Shift Tab Tab.
Why the Tab doesn't work for me?
I will go up. I will go up and check later.
Shift Tab. Okay, nothing. Okay.
Okay.
Go ahead.
All right. So right now it shows you like you can change S, which means size. C is color, and marker. You can change the marker style and CMap and many other things. So in this example, I chose you that on the second subplot, which this is my preference way to creating plots. I normally use AX for all my code, but I specified my subplots by adding AX equal to the subplot that I wanted to do. So this is just my style. You can also do AX in 1 like that, and it will show you the same result as well. All right. This is the way I normally write my code. And right now I change the data point for color to be red. And I wanted to add my data point with the edge line. And you can change the color as well. So the edge line can be black, or you can change it to be blue. And you can change it to whatever color you want. And K is normally a nickname for black. You can also type it black as well. And I believe it understands. And if you don't know how many color choice we have, you can also go into, you can search Google and search like color name, and it will show you the same, but you can also print it here, which will shows you the color list that ProPlot have.
Could you give it a specific number to represent one color?
Yes.
RGB or something.
Yes, we can do that as well. I think we can do that by
0, 0, 0, something like that.
See this, they understand this. Yes. Oh, no.
Oh, okay. No.
Is it 00 red? Let's just try changing it.
No, and there
Oh,
is
yes,
black.
yes. 000 is black in this
Yeah,
case.
yeah.
Okay, it's
Okay,
understand.
awesome.
All right. So that's how, yeah, RGB also work as well. All right. That's the first step. Change data color and add the edge and stuff like that. Next step. If we wanted to do things a little bit more fancier, which means we plot our data point as a gradient color.
Oh.
So that's similar to like 3-dimensional data on the 2D plot. So right now, what I'm doing here is I'm plotting SST versus text86. So text86 as our x-axis and SST data as our y-axis. And what I show you here is just another way. Instead of creating a new variable, you can just grab the column from your data frame right away, and it will understand the same thing. In case you don't want it to add new variables, it will understand that this is your x and this is your y, all right? And right now, when I wanted to color my data point based on latitude, I just have to put color and then said that I wanted to vary my data point based on latitude value. And this is our data frame, and we grab latitude column. And by doing that, ProPlot has a slightly different color map, default color map compared to Matplotlib. So here is the default color map for ProPlot, which you can see from here. It changes from white to slightly dark oranges.
And Moni, how did you know you use the ProPlot, not Matplotlib?
It's depending on what
I
command.
saw it.
So this is ProPlot. If you use plot, it will be Matplotlib. And in this case, if I use Matplotlib, it will don't understand the code because it's the way we code it is slightly different. And yeah, I haven't like going into details for Matplotlib.
Maybe they don't have scatter.
Yeah. Yeah, maybe I'm not sure whether Matplotlib has scatter or not. Like maybe we have to do plot and then we told them that we wanted to plot scatter inside. Yeah, I think if I remember it right, it might be something like this. It should be similar to this, which is plot, and then we add kind and scatter. No, we don't understand.
I see.
All right. Yeah, but it's slightly different. We can play around. So this is default color maps, right? But if we wanted to change color maps, it's similar to color names. We have to search. There are two things for ProPlot. There are color cycle. And color cycle is good for if you wanted to plot a categorical data, which means each color is discrete, right? But if you wanted to plot a continuous data, they also have a color map similar to what we have in MATLAB. So this is, I think this is an equivalent color maps that we normally use for MATLAB as well. And this is the name of each color maps, and this is the name of each color cycle. Color cycle is very specific to the ProPlot packages. I don't think Matplotlib have color cycle. So just to keep that in mind. All right. So now I just
I have a question here.
All right.
Could you create your own color bar?
Yes, we can. But I don't do it a lot. But yeah, we can do that. Yes. All right. Next, change color map. So we can change our color map by So right now, this line is the same as the previous example.
Mm.
What I add is that I tell ProPlot that I wanted to use color map named balance. So the balance color maps is the one that I think we generally use for sea surface temperature in MATLAB. This is balance, but it's a little bit like darker compared to the MATLAB version. So if you don't like these like darker colors, you can use cold hot as well. It will be slightly brighter. So if I change our CMap from balance to cold hot, try that. It will change to the new color map, right? And we can also like trim our color map value range by add vmin vmax. So if I didn't put vmin vmax, you can see that the color bar range is from 100 to minus 80, right?
Yeah.
But if we wanted to limit our like color bar, we can put vmin vmax. But it's still not show 90. So I just made it. I just made these example like right before our meeting. So I cannot really remember how I do it to really specify the label of the color map, but we can do that as well. If you wanted to show that our maximum value is 90 to minus 90, we can do something with the color map labels. All right. So I think that's what I have for these sections. Next will be the netcdf, but this is like just how to import Excel files or CSV files into Panda data frame and use it for scatter plots. But I haven't covered like regression analysis, which it might be a little more confusing comparing to MATLAB because we have to import another package for regression analysis. But we can also do that as well in Python, right?
Part 3.
Yes, part 3 we can do that
too.
too.
It was really, really cool.
All right. I hope that everyone getting something out of this.
Of course, I learned a lot.
Yes, a lot of shortcuts and smarter ways to do things. I was
I already forgot it. I haven't read it down because my code doesn't work for me.
Okay. All right.
Awesome.
All right. And
I hope next time Nora can join us because we deal with a lot of NC files.
Yes.
Yeah.
Okay.
Ronnie, thank you so much.
Thank
Amazing.
you for
Thank you
bearing with me as well.
No worries.
All right.
Oh yeah, I go dinner now.
Okay. Bye-bye.
Okay. Bye-bye.
Yeah. Come here, Ronnie.
Okay, I will go up.